More number of problems are there in Z transform, starting with standard problems, properties, problems using properties, and the inverse is a transform. Inverse is a transform itself. 4 different categories are there, and analysis of LTE system and stability checking. Okay, this particular topic is very important. So we will start directly the problem. Z transform. So Z transform of a discrete time sequence x of n represented by x of z equal to summation x of n z power minus n, where n varies from minus infinite to infinite. Okay. So what is DTFT formula? X of n e power minus j omega n. In Z transform formula, x of n z power minus n. Z is the complex variable here. Like Laplace transform, S was the complex variable, right? Here Z is the complex variable. And the value of Z equal to R e power j omega. So in Z transform, the region of convergence we represent in the form of circle only. So R is the radius of that circle. Radius of a circle. Okay. So this is the formula. Bilateral is a transform, standard formula. Suppose unilateral is a transform. Unilateral is a transform. If they specified unilateral is a transform, then we go with this formula. Summation n equal to 0 to infinite x of n z power minus n. This is unilateral Laplace transform. First one is bilateral Laplace transform or general formula. Okay. Or depending on the signal, we may change the summation limit. So remember this particular formula. N equal to minus infinite to infinite. Or in the question, if they specify unilateral, then you go with this formula. Okay. Now, what is the relation between DTFT and Z transform? Z is replaced by Z equal to R into e power j omega. So x of R e power j omega equal to summation n equal to minus infinite to infinite x of n Z replaced by R e power j omega Z power minus n. Okay. So if you replace Z by R e power j omega, you will get the equation like this. If you rearrange this particular equation, n equal to minus infinite to infinite x of n r power minus n, x of n r power minus n into e power minus j omega n. Okay. So from this particular equation, we can easily say the relationship between Z transform and DTFT. So if you find DTFT of a signal multiplied with R power minus n, then that will be equivalent to the Z transform. Okay. How CTFT Laplace transform we related? Similarly, DTFT and Z transform. DTFT of a given signal x of n multiplied with R power minus n. Okay. I'll write down. So equation 1 represent DTFT. DTFT of x of n r power minus n. Okay. That is your Z transform actually. But throughout this Z transform, we are going to use the variable Z. Okay. So like Laplace transform, here also the region of convergence concept available. So you will get x of z. Once you find z transform of a sequence, you will get x of z equal to in the form of bm z power minus m. Numerators, denominators 1 plus a1 z power minus 1 plus a2 z power minus 2 and so on, an z power minus n. So the roots of numerator called as poles, sorry, zeros. The roots of denominator called as poles. Okay. So in Laplace transform, we have plotted poles and zeros in S domain. Similarly, in Z transform, we can plot poles and zeros in Z domain. Z is the complex variable here. Okay. We represent Z equal to U plus JV. This is a real part and this is the imaginary part. U is the real part, V is the imaginary part. We will discuss how to mention the poles of Z transform and how to define the region of convergence in Z transform. Basic problems. First one. Find Z transform of x of n equal to a power n u of n. And find the ROC also. What is the region of convergence? The range of value of z for which x of z is valid. That is the region of convergence. In Laplace transform, the range of values of s for which x of s is finite or valid. Okay. So x of n equal to a power n u of n. General formula for z transform, summation x of n z power minus n, where n varies from minus infinite to infinite. But given problem u of n is there, so we all know that the unit step signal start from 0, 1, 2, 3 and so on up to infinite, right? Magnitude 1. So the summation limit is valid from n equal to 0 to infinite only. X of n equal to a power n, e of n value 1, z power minus n. So we can rewrite this equation 0 to infinite a power n formula. A power n formula. So 0 to n a power n. What is the result? 1 divided by 1 minus a. But what is the condition? The a must be less than 1. Just recall the formula. Note summation a power n. N varies from 0 to infinite. 1 divided by 1 minus a. The condition a must be less than 1. Right? So using this relation, we may find the region of convergence in Z transform directly. So 0 to infinite a power n. Result is 1 divided by 1 minus a. So in this example, 1 divided by 1 minus a is Z inverse. Or we can write this Z divided by Z minus a. Okay? If you multiply Z both numerator denominator, you will get Z divided by Z minus a, standard format. How to derive region of convergence? Summation 0 to infinite a power n. This entire term considered as a power n. So this formula is applicable. This formula is applicable when modulus a less than 1. That is modulus a Z inverse less than 1. Or we can write modulus a less than z, right? A by z. If z go right side, you will get this. Or z is greater than a. So the region of convergence for a power n u of n Z is greater than A. Okay. Finding ROC in Z transform is very simple. Whatever A power n, the term is there, we must relate that particular term less than 1. Okay. Now how to plot this in Z domain? This is U, variable U or real part of Z. Variable V. A standard representation, real part of Z. And here imaginary part of Z. Okay, in this example, Z equal to 0, right? Z divided by Z minus A. Numerator equal to 0. So only 1 0 available at the origin. Poles. How to find how many poles are there and what are the pole value? We have to equate the denominator equal to 0. Factorize first and equate it to 0. Well, only one term is there. So Z minus A equal to 0, Z equal to E. So how to plot 0? This is the symbol for 0. Z equal to 0 at the origin. Z equal to A. So A meaning this is origin, it will come right side, right? Somewhere you plot. This represent pole with A. Now region of convergence, modulus Z greater than A. So ROC, first we have to draw a circle with the radius of A. Draw a circle with the radius of A. So region of convergence, real part of Z greater than A. Greater than A meaning we have to draw or we have to show that ROC is outside the circle, right? Outside the circle. This indicate modulus Z greater than A. Okay. So A power n U of n. Remember, it's very important formula for solving inverse Z transform. A power n U of n. Z transform result is Z divided by Z minus A. And ROC modulus of Z greater than A. Right? Next formula. Second example. Find Z transform of x of n equal to minus A power n U of minus n minus 1. And region of convergence. First problem A power n U of n. Second example we have taken minus A power n U of minus n minus 1. Okay. First plot U of minus n minus 1. Minus n minus 1. So how to plot this signal? First time shift n minus 1. So n minus 1 signal start from 1 to 3 onwards. Then U of minus n minus 1. For this signal we have to take time reversal. Then 1 to infinite, now it becomes minus infinite to minus 1. This is U of minus n minus 1 signal sketch. So the formula for Z transform, x of n z power minus n. N varies from minus infinite to infinite. But now the summation limit changing from n equal to minus infinite to n equal to minus 1. Okay? Minus a power n. This entire term u of minus n minus 1 magnitude 1 only. Okay? Minus infinite to minus 1. Then formula z power minus n. We have to convert this summation into 0 to infinite. First step, replace n by minus n. Replace n by minus n. So how to write? Minus n equal to minus infinite. Minus n equal to minus 1. A power minus n. Z power plus n. Okay? I replaced all n by minus n first. Next, minus n equal to minus infinite. Or you can write it as n equal to infinite. N equal to 1. Okay. Next, minus a power n. We need a power n formula. So minus a inverse, right? Minus a inverse into z power n. Take this minus outside, no issue. So a inverse dot z whole power n. Right? So a power n, we got a power n format, but summation 0 to infinite not there. So summation infinite to 1 is same as n equal to 1 to infinite. Okay? Is 1 plus 2 plus 3 is equal to 3 plus 2 plus 1. Summation only. So you can rewrite 1 to infinite. Now a inverse is z power n. I need 0 to infinite. For that, what I am going to do, n equal to 0 to infinite. Indirectly, I am adding n equal to 0. If you substitute n equal to 0, anything power 0, 1. So I am adding plus 1 in this result indirectly. So to cancel that plus 1, I'm going to write minus 1. That's it. Okay. So a power minus 1 is at power n. Remember this minus for this term only. Okay. So now we got 0 to infinite a power n. Zero to infinite a power n. Apply the formula. 0 to infinite a power n. What is the result? 1 divided by 1 minus a inverse z. Okay. And this minus 1 is there. What is the region of convergence condition? A must be less than 1, right? So this entire term is a. A inverse z must be less than 1. That is nothing but z by a less than 1. So z is less than a. This is the region of convergence. To simplify this, minus, multiply this one. Minus into minus 1 divided by 1 minus a z inverse. So minus 1 into 1. B inverse is that okay? Okay. So if I do 1 minus A inverse Z minus 1. So 1 minus 1 plus A Z inverse, right? Okay. So summation n from 0 to infinite A power n. For that only this result. So keep this minus away. Keep this minus away. So cross multiply 1 minus 1 plus A inverse Z divided by 1 minus A inverse Z. So 1 will be cancelled. So your result would be minus A inverse Z divided by 1 minus A inverse Z. Okay. So minus A inverse Z divided by 1 minus A inverse Z. So this is your Z transform result. And region of convergence, A power n, this particular term. 0 to infinite A power n. Result is 1 divided by 1 minus A. The condition A must be less than 1. So A inverse Z must be less than 1. Okay. Now we have to bring this answer into a standard formula. Because A power n U of n, we obtain the result Z divided by Z minus A. Okay. So what we can do for this? I need Z divided by Z minus A format. Shall we multiply A both numerator denominator? So what you will get? Minus Z divided by A minus Z. Okay. Or if you multiply minus 1 both numerator denominator, or minus A both numerator denominator, then we will get Z divided by Z minus A. Okay. So what I did, I am just multiplied both numerator denominator by minus A. Okay. Then you will get Z divided by Z minus A. So x of Z equal to Z divided by Z minus A. The ROC for this particular problem, modulus Z less than minus A. Now check the previous problem. A power n U of n. Result is Z divided by Z minus A. But region of convergence, modulus Z greater than A. Second problem, minus A power n U of minus n minus 1. Minus A power n U of minus n minus 1. This particular problem also we will get the answer Z divided by Z minus A only. But difference is the region of convergence is less than A. The region of convergence less than A. Now plot your region of convergence. Pole 0 plot. Okay. Z divided by Z minus A. Factorize the numerator and equate into 0. So here Z only available, Z equal to 0. Pole Z minus A equal to 0, Z equal to A. So there is only one pole at Z equal to A. Only 1 0 at Z equal to origin. Z plane, real part of Z. imaginary part of Z A zeros at origin. Now draw a circle with a radius A. Check the region of convergence concept. Modulus Z less than A. Less than A represent inside the unity circle. So this is the region of convergence. Modulus Z less than A. Okay, even if it is minus A also, no problem. So you can write modulus Z less than modulus A. Okay. So these two are very fundamental formula. Minus A power n u of minus n minus 1. Z transform result. Result is Z divided by Z minus A. ROC modulus Z less than E. Second important formula. Right. Same concept as we discussed in Laplace transform. If the given signal is a causal signal, ROC is right-sided in Laplace transform, right? In Z transform, if the given signal is causal signal A power n u of n, then your region of convergence outside of a circle. If the given signal is non-causal signal, u of minus n minus 1 is a non-causal signal because the information exists for the negative values of n. So if non-causal signal present, the region of convergence inside a circle. Understand? Okay. Then another concept we studied in Laplace transform. If more than one causal signal given, then what about the region of convergence? The region of convergence right side of rightmost pole in Laplace. Here, if more than one causal signal given, then ROC is outside of outermost circle. If more than one non-causal signal given, then region of convergence is inside of innermost circle. Okay. So we'll solve some problem, but you should remember this concept. Causal signal outside of the circle, ROC. Non-causal signal inside of this inner circle for the non-causal signal. If one causal, one non-causal mixed together, then based on the value, whether between two circle or inside the inner circle, we have to describe. So we will get a better understanding. Suppose A power n u of n signal minus A power n u of minus n minus 1. So I'm not giving A, I will take some other variable. B power n u of minus n minus 1. Find the Z transform and mention the region of convergence. Okay. So now I'm not going to solve separately in detailed manner because just now we completed A power n u of n. What is the result? Z divided by Z minus A. Okay. Minus B power n u of minus n minus 1. What is the result? Z divided by Z minus B. But ROC, condition for ROC, first term, Z is greater than A. Condition for ROC, second term, for this particular term, Z is less than B. So whenever if you are finding Z transform of more than one signals are mixed together, you have to simplify and write down the final answer. Z minus A, Z minus B. So Z into Z minus B plus Z into Z minus A. Further simplify and write down your final answer. Now how to mention the region of convergence? Because first term ROC is greater than modulus A. Second term ROC is less than B. Okay, just now we derived, right? Okay. Now assume two cases. mentioned region of convergence. Now our interest is pole only. So real part of z in x-axis, imaginary part of z in y-axis. Z equal to A, Z equal to P. There are two poles now. The roots of the denominator, right? Z equal to A, Z equal to B. Suppose if I assume A is less than B, hmm? A is less than B. This is a condition. So draw a circle, draw another circle. Okay. This is the case when A is less than B. Now how to specify ROC? Modulus of Z greater than A, modulus of Z less than B. Or shall we summarize these two? Greater than A, less than B. Is it okay? Same, right? Z less than B, Z less than B. Z greater than A, Z greater than B. Okay. So modulus of Z greater than A. Greater than A meaning outside of the circle. Less than B meaning inside of this circle with a radius B. Okay. Inside of the circle with radius. So in this case, Z between A to B. When we consider A less than B. Okay, because problems in general format. Suppose A greater than B if you are assuming. B and then A. Draw a circle. Now we have to satisfy the condition Z is greater than A. Okay, Z is greater than A. The radius of the circle with A, this one. So greater than A meaning you have to show like this. And less than B meaning inside the circle. So this is the case. Z greater than A, less than B. So there are two cases possible. Case 1, A less than B. How to show region of convergence? Second case is A greater than B. Now how to show your region of convergence? Your ROC should not include the poles. Same concept in Laplace transform also. ROC should not include the poles. Okay. Either outside a circle or inside a circle. Or between two circles. So any doubt? Are you clear about this region of convergence concept? Yes, in Laplace and Z transform, this is must for solving all the problems. Z transform, it's very simple because when you are trying to solve the problem 0 to infinite a power n format, this a less than 1, if we equate this particular term is less than 1, then you will get the region of convergence answer easily. Okay. In Laplace, you have to check for what range of values you will get finite value. Okay. But Z transform finding ROC is very simple. So we solve two basic formula as well as a power n u of n minus b power n u of n u of minus n minus 1. How to represent the region of convergence? Okay. Then many small problems are there. Suppose a sequence given x of n equal to 1, 2, 0, minus 4, 3, 2, comma 1, comma 6, comma 5. And also they mention x of 0. Okay. Now find ROC. Sorry, find Z transform. For this sequence, find Z transform. Now how to check or how to find Z transform? Just substitute x of n value. General formula. So this is x of 0, right? Arrow mark indicate x of 0, x of 1, x of 2, x of 3, x of 4. This side x of minus 1, x of minus 2, x of minus 3, x of minus 4. Okay, you got an idea? So x of 0, 1, 2, 3, 4, x of minus 1, minus 2, minus 3, minus 4 away. Try to expand this equation. X of minus 4 z power n minus 4 meaning minus into minus plus 4 plus x of minus 3 z cube plus x of minus 2 z square plus x of minus 1 z x of 0 z power 0 z power 0 1 x of 1 z power minus 1 x of 2 z power minus 2 x of 3 z power minus 3 x of 4 z power minus 1 and substitute the value for x of 0, 1, 2, 3, 4 up to x of 4. And you will get the answer. So sequence given also, you should be ready to solve the Z transform for the given sequence. Okay. Similarly, only positive side signal may be given or only negative side signal may be given. But anyway, compare with the fundamental formula, you complete it. So x of z minus 4 z power 4. You will get z power 4 plus 2 z cube z square x of minus 2 0. So this term will be 0. Next minus 4 z minus 4 minus 4 z plus 3 plus 2 z power minus 1 plus z power minus 2 6 z power minus 3 plus 5 z power minus 1. So this is your result. Okay. To write region of convergence for these kind of problems, both sided, right? In this kind of sequence given, ROC x of z converge all values of z except at z equal to infinite and z equal to 0. Okay. If double-sided signal given, the region of convergence converge in all the values of s except z equal to infinite, z equal to 0. Suppose positive sequence only given, that time we have to mention converge all the values of z except at z equal to 0. An example I will give you. For the sequence, double-sided sequence we discuss now. Suppose 2 comma minus 1 comma 3 comma 2 comma 0 comma 1. Please mute your mic. 119. Problem number 119. 3 comma 2 comma minus 1 comma minus 4 comma 1. Okay, so this one like this. How to find x of z? Follow the same procedure. Okay. X of 0, x of 1, 2, 3, 4, 5. This is x of 0, x of minus 1, x of minus 2, x of minus 3, x of minus. Okay. So I will get x of z term 2 minus z power minus 1 plus 3z power minus 2 plus 2z power minus cube plus 0 plus z power minus 5. Answer for this. I mean, ROC all the values of z except z equal to 0. Suppose the negative sequence are provided, x of z, compare with the standard z transform equation. This is x of 0, x of minus 1, x of minus 2, x of minus 3, x of minus 1. Okay. So we will get 3z power 4 plus 2z cube minus z square minus 4z plus 1. So this kind of negative sequence except at z equal to infinite. Okay. So positive side except at z equal to 0. A negative sequence provided except at z equal to infinite. If both sided given except at z equal to 0, z equal to infinite. Okay. So apart from sequence a power n u of n given or a power n u of minus n minus 1 given, then we have to solve the problem and identify the region of convergence. The condition for region of convergence. So do you have class for next term? Is there class next term for you?
Yes, sir.